Hello and welcome. It gives me great pleasure and privilege to be talking in front of all of you. I also feel fortunate to represent a team of AWS team members, 25 AWS team members. You all decided to come here since you're curious about innovation in public health. And this talk that we are going to be delivering today is about how we implemented a collaborative public health data platform for the county of Santa Clara in the Golden State of California. My name is Rajiv Shirgupi. I'm a senior engagement manager with Public Sector ProServe. And I'm joined with my colleague, TJ, who is a senior consultant in Public Sector ProServe as well. And we are going to walk you through how we implemented a comprehensive public health data platform for the county of Santa Clara in the Golden State of California. So on the agenda today, we'll walk you through the business impact story, what the business challenges were, and what were the personas and their problems. Essentially, we'll walk you through the data flow overview. TJ is going to walk you through the solution architecture and a couple of use cases. And then we'll end with business and technical outcomes and lessons learned from our implementation story. All right, let's dive in. A little bit about the customer first. The mission of the public health department at the county of Santa Clara is to improve and protect the health and well-being of its constituents. It serves 2 million plus constituents. It works with 70 partner agencies, primarily with the California Department of Public Health and with system integrators like Amazon. And it serves 15 cities in the county. What we did is, this was a flagship implementation for the county. We implemented a public health data platform with 15 public health data sources, with over 50 million records ingested on a weekly basis. That created about 150 ingestion views and 300 plus curation and distribution tables that are available for analysis. And on the visualization layer, we had 150 reports and dashboards and over 60 plus dashboards that we presented to the team for analysis and reporting. In this digital age, data fuels innovation. So this survey by MIT and Databricks shows that only 13% of the organizations effectively use data as part of their data strategy to achieve their business goals. So we had a very similar challenge with the County of Santa Clara Public Health Department. The challenge was that epidemiologists and data scientists had to work with siloed and fragmented data, and they spent a lot of time wrangling data, unifying it, instead of analyzing it and using it for reporting with meaningful insights. As part of the implementation team, we worked backwards from the business outcome of getting all the structured and unstructured data into a scalable and secure data lake platform. So the data was ingested using ETLs and then pushed through data pipelines into a myriad of on-prem and cloud-based endpoints. And the key benefit that the public health department received was a scalable, secure, cost-effective, and accelerated AWS solution that gave them access to automated, centralized, and harmonized public health data that they could use for analysis and reporting. Let's dive into the personas. So as part of the working backwards process, 2 personas bubbled up. One, Tom, a relatively new epidemiologist that the county had hired for reporting and analytics purposes. He has to deal with large and messy data sets and use that for analysis. And he really wants automated reports that are on validated data sets. And second, Dr. Santa Clara, who is a busy healthcare officer, and she is grappling with incomplete data, which doesn't give her a complete disease surveillance picture. So she needs data for decision-making in a timely manner that she can use to report to her leadership and ultimately serve the constituents and its agency. So how cool would it be for Tom to just sip coffee and have automated reports with validated data sets at his fingertips. And how cool would it be for Dr. Santa Clara to have reports and the ability to query data to answer her questions? Let's dive into the data sources. So starting with the key data source, the major data source that we used was COVID-19. This primarily was sourced from CalReady COVID. CalReady stands for California Reportable Diseases Information Exchange. That represented majority of our data set, CalReady COVID-19 and CalReady infectious diseases, followed by immunizations, which is the vaccination data, and then contact tracing data, which is CalConnect. It provides details on exposures, and syndromic surveillance that monitors health indicators for public health importance. Vital stats, which is EDRS CalIvers, which represents the birth and the death data. And there were 15 data sources in total. We are only presenting 5 or 6 since the time is short. And the data lake platform provided operational and information, descriptive data like reports and dashboards, diagnostic details, predictive insights, and prescriptive information that the EPIs could execute on. And we would dive into some of the use cases and the solution architecture here in a bit. And with that, I'll turn it over to you, TJ.
Thanks, Raju. So let's now go into the technical architecture and the data flow overview. So as Raju was mentioning about those 15 data sources which we acquired, so here as you can see, these external data sources, once they get into the ingestion layer, the data is validated, it's standardized, and also obfuscated for the PII data, so the person data which is identified. We are using AWS Glue Data Brew here, but you can also use Amazon Macy for the same purpose. Data is cataloged using the crawler and also labeled. So there are a couple of AI/ML use cases we are going to dive deep into where the data is labeled at the ingestion layer. The ingestion layer data is stored in the landing layer in S3 bucket. Then the curation layer where data is curated with the business rules are applied. We used SQL-based ETL DBT or the data build tool. This is a open source third-party tool. This was a customer selection, but you can also use AWS Glue for ETL. At the curation layer, data is stored in the ingestion optimized model or the data vault model. This is also known as hub satellite model. And this is that time the data is stored is in Aurora Postgres SQL DB. And the last layer, the distribution layer, this data is transformed into the query optimized model, which is a dimension and fact tables. So query optimized model is stored in Aurora Postgres and also extracted in the data lake or S3. On all the layers, data is encrypted using KMS. The error handling is managed by Amazon CloudWatch and the notification by SNS. So this is high level data flow. Let's now dive deep into the architecture. This is a solution architecture. So as you know, the external data sources which are coming from multiple systems and they're coming in multiple formats. We have some Snowflake integrations which we can directly access the Snowflake views or the Parquet files. There are API endpoints integration or sometimes even the unstructured data in PDF format which comes as an email attachment. Now for each data source, there are different parameters, the type of data which is coming, the schedule, how the data will be ingested. So as you can see here, this is the multi-AWS account architecture, which gives us the higher security by isolating the environments. At the same time, granular security can be applied. So the core account is the orchestration. So core account is mainly responsible for orchestrating by using the step functions. And now here what you see, DynamoDB config, that is a configurable table. So all the configurations for these external data sources are the parameters are stored there. This is the type of data, the schedule. If the data contains PII, any person data, as you can see, identity management, this is one AI/ML use case which we are going to dive deep into. That is invoked if the data has a person data. So when the orchestration layer, the core account, based on the configuration, the data types. It actually invokes the respective function. It could be AWS Glue or Lambda or Textract in case of PDF file. Data gets stored in the landing layer. Its metadata gets created with the crawler. And now identity management will also invoke if it is a PII data. In the next step, data sync process gets invoked, where your transformation layer or the ETL layer is invoked. As you can see, the DBT code is also managed by AWS Code Build. So AWS Code Build is fully managed code build solution, which compiles, run your test, and deploy the code. At the transformation layer, the staging objects, which are the views, then the curation vault, which is hub and satellite tables, and the distribution objects, which are dimension and fact tables, get created. This data is again stored into Aurora Postgres, and in the data extract layer, only the dimension and fact tables are getting extracted to the consumption layer, which is a S3, is a data lake, which is available for the end user consumption. So end user endpoints, right now they're using Esri, RStudio, or Power BI. Like Raju mentioned, our epidemiologist Tom or Dr. Santa Clara, they can now directly access data from that S3 bucket, which is available for the consumption layer in the dimension and fact mode. The entire architecture is secured and governed by using AWS Data Lake formation, which is RBAC, or role-based access control by creating roles in IAM. The AWS KM is used for the encryption of data. Data is for the threat modeling, Amazon Guard Duty is used. For monitoring and observability, Amazon CloudWatch and Amazon SNS services are used for error handling and notification. CI/CD pipeline. So we are using AWS Code Commit, Code Pipeline, and Code Build for the automated CI/CD. Unfortunately, some of you may know that Code Commit is deprecated for now. It is supported for the customers who are using it, but going forward, we can use GitHub or any other related services. So just in brief, I can just say that this entire architecture is automated. So for any data source, once the file gets ingested and gets dropped into your S3 bucket, the CI/CD pipeline gets kicked off, and less than 50 minutes, average 50 minutes, the data is available at the consumption layer, fully automated pipeline. For the configuration is scalable, because if any new data source gets introduced, we have to just add that item into the DynamoDB config table, and with very little or none change to your ingestion code, that new data source can be adapted into the data lake. Now let's dive deep into one of the AI/ML use case, which we talked about, the identity management or the golden record. So let's talk about our friend John Doe. So John Doe is just like one of our friends. Sometimes we feel under the weather, and John Doe goes and sees his doctor. His doctor sends him to the lab. He gets tested. Unfortunately, our friend is tested positive. He gets treated for that. He gets recovered. After a few months, he gets vaccinated for that virus. And then after a few months, he might get reinfected by something else, and the cycle continues. And this happens for many of us. Now, all these incidences coming in our system from different data sources. And each data source identifies John Doe as a unique person. So they have their own unique ID. They might spell his name differently, sometimes Jon, sometimes Jhon. The addresses are stored differently. The phone numbers are formatted differently. So how will we identify in our system? This is just one person going through this entire cycle. So for that, just to dedupe that data, we are using AWS Glue Find Matches ML transform. So this ML transform helps us to identify duplicated records and the matching records. So that's how we can get that golden record using the business logic. So let's go over the architecture real quick. So for the identity management, once, as I was mentioning, some of the data sources, they have that PII or the person data. So once that data gets standardized, so for that we are using Amazon Location Service. Amazon Location Service is for address standardization. So it has a geocoding or mapping data. The addresses are standardized by using ALS. Phone numbers, names are standardized, and the standardized data gets stored into S3 along with the label data. So if you remember that slide when we said ingestion layer is labeling the data, so data scientist has labeled the test data. So that test data, the label data, and the standardized data gets fed into the Amazon Glue find match, and this is where the model runs to get the threshold evaluation for the accuracy, precision, and error rate. We also have a human in loop there so that the data scientist can also make sure the data which is identified by find matches is correct. So that in that iteration, until we achieve the accuracy with the ground truth, after that we get the EMPI or the Enterprise Master Person ID created. So our friend John Doe's 5 records come in the system, and all 5 records are tagged with one unique ID, and that's where the analyst or Dr. Santa Clara, she knows that this is just one person for accurate statistics or even going through one person's journey. The next AI/ML use case is text track. And this is again one of the data sources where, if you all remember, when COVID pandemic hit, there were a lot of pop-up facilities open, and not all those facilities had systems in there. So many times we ended up writing handwritten forms. Now those handwritten forms, when they came in the system, now we are extracting those forms, an email parser, and now text track is used because text track is a text detection OCR. So this is Amazon service for text track, which just extracts the data from those forms, and we're using custom query. So custom query is just using NLP to ask questions. What is the patient's name? What is the address? Was he positive for COVID? Just by answering those questions, the data is extracted. Again, we're using Amazon Augmented AI or A2I as a human in loop to make sure the data which is extracted by text track is accurate. So once we get that accurate data, now this data from PDF is now stored as CSV to the data model and available in the data lake. So this is what we just went over, high-level architecture, and these are the couple of AI/ML use cases. So back to you, Raju, and Raju will walk us through business outcomes.
Thank you. Appreciate it. All right, these were very interesting use cases, and if you have questions about these use cases, we'll be in the AWS Village in the ProServe kiosk. Feel free to stop by and we can answer your questions then. Let's quickly touch upon some of the business and technical outcomes that we received as part of the engagement. We deployed 13 out of the 15 data sources. The last 2 are still being developed, and 13 are currently in production. That gave them 150 plus ingestion views, 300 plus curation and distribution tables available for analysis. TJ covered the identity management use case that's applicable for 6 data sources. We had the PDF handwritten forms ingestion using text track for the CRF CMR data source. And with automated integration and deployment, over 50 million plus records are ingested on a weekly basis, under 50 minutes average processing time. So these were some of the key business and technical outcomes that we got as part of the implementation. And there's a QR code if you want to pull up your phones and scan that QR code. That will give you access to publicly available dashboards on the Santa Clara County website. We have a minute left. Just going to quickly touch upon the key lessons learned as part of the agile retrospectives that we did as part of the implementation. The number one thing was think big, start small, and get excited. We knew that the think big picture was right there, front and center, but one of the things that we learned as part of the retrospective is we had to do a single data source, then roll out the solution, and then attack the other 14 data sources. It's very easy to overcomplicate things and do analysis paralysis, so I would recommend not overcomplicating things. Just stick to a decision and move with it. This is an interesting one that came as part of our technical retrospectives, inclusion of data modeling efforts as part of the implementation that helped the development team. Access to production-grade data in lower environments. This was really important for test data management and also development. So think about this as part of your data engagements. And last but not the least, finish what you start, working backwards from the business outcome. So with that, TJ and I would like to thank you for sparing your time and attending this session. If there are any questions, we would be available in the AWS Village for any discussions. And feel free to actually complete your session survey while you're still here. Your feedback is extremely important to us, so take a few minutes to complete the session survey. Thank you so much.
Thank you.